Okay, guys. So like I said, some of these that before we can actually get them into a linear or a quadratic form, we're going to have to do some trig identity substitution. So you guys have out your formula sheets to refer to. So some trig equations involving using trig substitutions. How do you know when you're going to have to do a trig identity substitution? You need to make sure, if possible, to try and get the equations in the form of one trig function. So if you're looking at an equation where you see more than one trig function, that's when it's a red flag. You may have to do some type of trig identity substitution. And again, this is if a GCF factoring does not work. Because last night for homework, we did have equations where you had more than one trig function. But you were able to set your equation equal to 0 and then do GCF factoring and then use your zero product property to solve. So these are some common trig identity substitutions that you have to be on the lookout for. Pythagorean identities, which is on your blue sheet. So if you remember your Pythagorean identities, sine squared plus cosine squared equals 1. And remember, you can algebraically solve this for sine squared by subtracting cosine. Remember, you also have those other variations. You also have the tangent squared plus 1 equals secant squared. And then you have 1 plus cotangent squared theta is equal to cosecant squared theta. So we do use those Pythagorean identities quite a bit when we are solving these trig equations. Another one that comes up quite a bit is your reciprocal identities. So remember, the reciprocal identities is when tangent of theta is equal to sine theta over cosine theta. Oh, you're right. We'll change this word to quotient. See, I'm still on my snow day. We use quotient identities too. That was going to be number 3. So we use quotient identities too. So your quotient identities, remember, tangent is equal to sine over cosine. Cotangent of theta is equal to cosine theta over sine theta. So we use those two. And of course we use our reciprocal identities. So remember, by your reciprocal identities, we have sine of theta is equal to 1 over cosecant theta. And then we have cosine theta is equal to 1 over secant theta. Tangent of theta is equal to 1 over cotangent of theta. And then, of course, we have the other versions as well, the other 3. Your sine double angle formula comes up quite a bit. So the sine double angle formula is the sine of 2 theta, remember, is equal to 2 sine theta cosine theta. And then the last one, the cosine double angle. Remember, you've got 3 variations of the cosine double angle formula if you look on your blue sheet. And that is the cosine of 2 theta is equal to 2 cosine squared theta minus 1, which is equal to 1 minus 2 sine squared theta. And then you also have the cosine squared minus sine squared variation as well. So these are very common trig identity substitutions that we'll be looking at when we have to solve some trig equations. again, notice we are solving over a particular interval from 0 to 2 pi. So we're just looking for one revolution. So let's take a look at number 1. Cosine theta plus sine theta is equal to 0. So notice I cannot do GCF factoring. There's no GCF factoring I can do. So the issue is I've got more than one trig function in this equation. So looking at all the identities that we know, when you have a sine to the first power and a cosine to the first power, is there a particular trig identity or trig function that comes to mind when you deal with sines and cosines? They're not squared, so we can throw Pythagorean identities out the window. Sine and cosine. There should be at this point of the game, what trig function comes to mind when we think of sine and cosines? Quotient, the tangent. Because what is tangent equal to? Tangent's equal to what? Sine over cosine. So that's exactly what I'm going to use here in number 1. So my first step is I'm going to subtract a cosine on one side of the equation. Because now somehow, some way, we need to manipulate this equation algebraically to get it in the form of sine over cosine. So now that I've separated the sine and cosine on opposite sides of the equation, what can I do to both sides of the equation? I can divide both sides by a what? To get a sine over cosine, what can I divide both sides of the equation by? Cosine. So now I have sine theta over cosine theta is equal to -1. This is not like we did what I've warned you about. You're not dividing cosine out of the entire equation. You still have the cosine. It hasn't disappeared. But now, how can I rewrite sine over cosine? Sine over cosine is equal to what? Tangent. So now, notice your objective's been made. You now have an equation with a form of one trig function. All right, so any questions on how I rewrote that particular equation? So again, the more familiar you are with those identities and you know what trig functions go together with which ones, which is why you had to memorize them back in Unit 4. Because really, you have to know them in order to be able to solve these trig equations. So any questions where we got tangent of theta is equal to -1. So now you're back to the unit circle. So where is tangent equal to -1? What two quadrants are we looking in? 2 and 4, exactly. So what's the angle in quadrant 2 that has a tangent value equal to -1? 3 pi over 4. And then the angle down here in quadrant 4 would be what? 7 pi over 4. Okay? So any questions on number 1? So look at the trig functions that you have in the equation and ask yourself, what relationship, what trig identities do I know where those two go together? So that's why it's helpful to know sine squares and cosine squares, those are your Pythagorean identities. The secant squares and the tangent squares go together in the Pythagorean identities. So knowing those relationships help you kind of give you that jump start in terms of where you're looking. So now let's take a look at number 2. You have tangent is equal to cotangent. Even if I set this equal to 0 and move the cotangent to the other side, would GCF factoring help me? No. So now look at the relationship between tangent and cotangent. What is the relationship between tangent and cotangent? What are they of one another? They are what? Reciprocal. So guess what identity we're going to use? We're going to use our reciprocal identities. Because again, does it matter if I change it into all cotangent or all tangents? No. It's an eeny, meeny, miny, mo. But remember, by your reciprocal identities, I know that cotangent of theta is equal to 1 over tangent. So then, again, like I said, if you wanted to change tangent into terms of cotangent, you could do that as well. So again, I'm going to change cotangent into 1 over tangent. Any thoughts on how I'm going to solve this equation? Again, if you're stuck on the algebra, you could at this point let x be equal to tangent and rewrite it as x equals 1 over x, if that helps you. Any thoughts here, George?
Multiply both sides by tangent.
Multiply, remember, clear that fraction out of the equation, so I'm going to multiply everything by a tangent. So I'll give you a tangent squared theta is equal to 1. Again, remember, algebraically, if you're stuck, you can let x be equal to tangent of theta if that helps you get you through the algebra. So x squared is equal to 1. How do you solve that? Square root both sides. Or could you get as 1, subtract 1 and then factor? Yes. So x equals, what do you have to remember to put in front of the square root when you take the square root of both sides? Plus or minus. Don't forget that plus or minus. So now bring your tangent back in. Where is tangent equal to plus or minus 1? What quadrants are we looking in? All of them, because again, we're looking for where it's positive and negative. So then, what angle in quadrant 1 has the tangent value of 1? Pi over 4. In quadrant 2, it's going to be what? 3 pi over 4. In quadrant 3, it'll be 5 pi over 4. And then in quadrant 4, it'll be 7 pi over 4. So any questions on number 2? All right, let's take a look at number 3. So now number 3 is not the same as number 1. How come they're a little different? How is number 3 different than number 1? Because you have a what? Square. You have a sine squared. So you have a sine squared and you have a cosine. Remember, Pythagorean identities only work for squares. So remember, the objective is, if you can, rewrite the trig equation in just the form of one trig function. Right now you've got a sine squared and you've got a cosine. So the only thing we want to zero in on is, how can I get rid of this sine squared and write it in terms of a cosine? You have those Pythagorean identity substitutions. So when you see a sine squared and a cosine in the same equation, remember, by your Pythagorean identity, sine squared is equal to 1 minus cosine squared. So at least if I can take out this sine squared and replace it with a 1 minus cosine squared, I'll have an equation that has just one trig function. So I can write this as 1 minus cosine squared theta. Again, I took out that sine squared and replaced it with the 1 minus cosine squared. Equals 2 cosine theta plus 2. So any questions on where I got the 1 minus cosine squared from? Now, like I said, if you don't know what to do with the algebra, take out your cosine and replace it with an x. So we have 1 minus x squared is equal to 2x plus 2. So like I said, if you're not sure what to do it with the cosines, take out that cosine and put it in the x. All right? How do you start solving this? Is this a quadratic or a linear equation? Quadratic. What do you have to have on one side of the equation to solve any quadratic equation? 0. So I'm going to go ahead and move everything over to the right. So 0 is going to be equal to x squared plus 2x. I add x squared to both sides, and then I'm going to subtract the 1. So that'll give me a plus 1. How do you factor x squared plus 2x plus 1? What does that factor into? That factors into a what? X plus 1 times x plus 1. So then x plus 1 equals 0. So x is equal to what? Negative 1. So any questions where I got the negative 1 from? So now what do I have to replace x with? This is where I'm going to replace x with what? Cosine. So cosine of theta is equal to negative 1. So now you have to ask yourself, where is cosine equal to negative 1? Well, is cosine what? The x or the y coordinate? X. So you're looking to see, where is your x coordinate equal to negative 1? Pi. So theta is going to be equal to pi. So any questions on number 3? Look at number 4. Number 3 and number 4 are very similar. Cotangent squared minus cosecant is equal to negative 1. Notice you've got a trig function squared, you've got a linear trig function. Two different trig functions. GCF factoring is not going to help you. But you do have Pythagorean identities on that trig function to the second power. Remember, that's where it's helpful to know what two trig functions go together, your Pythagorean identities. Remember, 1 plus cotangent squared is equal to cosecant squared. Cosecants and cotangents go together with those Pythagorean identities. So then cotangent squared theta. I just wrote at the top that 1 plus cotangent squared is equal to cosecant squared. Oh, I'm sorry. So I just wrote this at the top. I just wrote 1. I did not write all the variations of this. So the idea is I want to get rid of this cotangent squared and replace it with a Pythagorean identity substitution. So I need to solve this for cotangent squared. So cotangent squared is equal to cosecant squared theta minus 1. So I can take out my cotangent squared and replace it with a cosecant squared minus 1, because then at least I have an equation in the form of all cosecants. So I have cosecant squared theta minus 1 minus cosecant theta is equal to negative 1. Again, if you're not sure what to do with the algebra with the cosecant, do your substitution. Take out the cosecant and replace it with an x to get you through the algebra part. So x squared minus 1 minus x is equal to negative 1. What kind of equation is this? Is this a quadratic or linear? Quadratic. So what do you need to have on one side of the equation? You need to have a what? 0. So if I add 1 to both sides, what happens with that minus 1 plus 1? They're going to do what? Cancel. Now how do you factor that? What are you going to do? Take out a GCF. So you guys go ahead and finish factoring that for me. So hopefully, guys, we got it down to this point. Cosecant theta equals 0 and cosecant equals 1. So any questions on how I got it down to this part? So let's take a look, first of all, where is cosecant equal to 1? Well, cosecant's reciprocal of the what? Sine. So we're looking to see where is sine of theta equal to 1. So where is sine equal to 1? Remember, sine is your y-coordinate, so you're looking to see where the y-coordinate is equal to 1. Remember, the y-coordinate is equal to 1 up here on the positive side of your y-axis. So what angle is this? This is at angle what? Pi over 2. Because the reciprocal of 1 is 1. Now the issue we went into, sine of theta is equal to 0. Well, what's the reciprocal of 0? Undefined. Is there any place where sine is undefined? No. So this can't be solved. If you remember, the range of cosecant is all real numbers less than or equal to negative 1, or all real numbers greater than or equal to 1. 0 is not in the range of cosecant, so it does not have a solution. All right? So there's only one solution here when theta is equal to pi over 2. So any questions on example 4? Okay? Let's take a look at example 5. Number 5 is very similar to what we just did in problem numbers 3 and 4. Because remember, with Pythagorean identities, the tangents and the secants go together. So if you look what I wrote down here under your Pythagorean identities, tangent squared plus 1 is equal to secant squared. So the idea here is we need to get somehow, some way, get rid of this tangent squared. I can't do anything with secant. Because remember, Pythagorean identities have to only be when you have trig functions squared. So you can't change that secant. So the only thing you can do is change that tangent squared. Again, by your Pythagorean identities, tangent squared plus 1 is equal to secant squared. So that if I subtract 1, tangent squared is equal to secant squared theta minus 1. Again, remember, the objective is, in order to solve these trig equations, you want the equation in the terms of just one trig function. So right now you've got a tangent and a secant, so we want to try and get it in the form of just one. So I can take out my tangent squared and replace it with a secant squared theta minus 1. Now, be careful you have a coefficient of 2. So when you do this substitution, you want to make sure that you place secant squared theta minus 1 inside parentheses. Minus 3 secant theta plus 3 is equal to 0. So any questions on that substitution that I did? So like I said, at this point, to get you through the algebra, do that substitution. Take out the secant and replace it with an x. So I can rewrite this as 2 times x squared minus 1 minus 3x plus 3 is equal to 0. What's going to be your first step here? Distribute. So any questions where I got the 2x squared minus 2 from? Then what? Come on, like perms. What can I combine? I can combine the what? The 3 and the negative 2. So that'll give me a 2x squared minus 3x plus 1 is equal to 0. Then what are you going to do? Then what are you going to do? Factor it. So go ahead and factor that for me. Again, some of you may use that x method, use that just do it. Some of you may use slide and divide. Again, I don't care which method you use as long as you factor it. Again, if you still don't have no idea how to factor these quadratics with a leading coefficient equal to a number, we need to get in here and do some practice, okay? Whenever we have rule block again. You got it down to where x is equal to 1 and x is equal to 1/2. So this will factor into x minus 1 times your 2x minus 1. Okay? So any questions where I got the x equals 1 or x equals 1/2 from the factorization? So now what do I need to bring back in? What was x originally equal to? X was equal to what? Secant. So I want to know where is secant theta equal to 1 and secant theta is equal to 1/2. Well, secant's reciprocal of the what? Cosine. So I need to know where is the cosine of theta is equal to the reciprocal of 1 is 1. So now where is cosine equal to 1? Remember, cosine's your x-coordinate. So where is your x-coordinate? At what angle is your x-coordinate equal to 1? At what? 0. Remember, right here on your positive x-axis is where you've got the coordinate 1, 0. So then theta is just going to be equal to 0. Secant of theta is equal to 1/2, so I need to find where is cosine theta equal to 2. Is there any place where cosine is equal to 2? No. Remember what I've been mentioning to you. The range of cosine and sine is from -1 to 1. 2 is outside of that range, so this part has no solution. So you only have the one solution where theta is equal to 0. So any questions on example 5? So now let's take a look at example 6. Example 6 is different than all the other 5 because what's sitting in front of theta that none of the equations have had before? Theta has what in front of it? A 2. When you see this 2, right away there's only one identity that we have to get rid of that 2, because I can't solve an equation when there's a coefficient in front of theta. Which identity am I going to have to use? The double angle formula. So when you see that 2 theta and it's a sine, that's right away that it's going to be your double angle formula. So remember, the sine of 2 theta, your double angle formula for sine, is 2 sine theta cosine theta. So again, you've got to get rid of somehow, some way, rewrite it so that you do not have that coefficient of 2 in front of theta. So I can replace this whole sine of 2 theta with 2 sine theta cosine theta is equal to 2 sine theta. Can I divide both sides of this equation by 2 sine theta? No. Don't do that. Don't follow that instinct. So what do you want to get on one side equation? We want to try and get a what? 0. So when that instinct hits you guys, When you want to divide both sides of an equation by a trig function, that's a red flag. Don't do that. That's where your GCF is going to help you. That's going to be your GCF factoring. So get the 0. So when that instinct hits you, you want to divide both sides of the equation by that trig function and have it cancel out. Don't do that. That's when GCF factoring is going to work. So I'm going to subtract 2 sine theta on both sides. And again, algebraically, if you're stuck, you could let x be equal to sine and y be equal to cosine if that helps you. Now, what is your GCF you can factor out? What can you factor out of everything? 2 sine theta. So I divided 2 sine theta out of here inside my parentheses. That leaves me with a cosine theta. Minus 2 sine theta divided by itself. Remember, you just don't write anything. You've got to write that 1. Again, like I said, if you're not sure what to do with it, sine and cosine, you could rewrite it in terms of x and y. Now set each factor equal to 0. So I can divide a 2 on both sides, so I have sine of theta is equal to 0. Sine is what? Your x or y coordinate? Y. So we're looking to see where is your y coordinate equal to 0. So your y coordinate's equal to 0 where? 0 and pi. Because you have the ordered pair 1, 0 and negative 1, 0. So you have theta is equal to 0 and pi. So that I have cosine of theta is equal to 1. Cosine is what? Your x or y coordinate? X. So we're looking to see where is your x coordinate equal to 1. Your x coordinate's equal to 1 where? 0, which I already have in my list. I don't need to write it twice. I mean, I wouldn't mark it wrong if you did, but okay. So any questions on this one? Number 7. What do you think you're going to have to do in number 7? Double angle. You guys go ahead and try number 7 on your own. Okay, guys, when you're done, after you do your double angle substitution, the GCF you can factor out as a cosine. All right, and then again, you set cosine equal to 0, and you have the 2 sine theta plus 1 equal to 0. So where cosine is equal to 0, where your x coordinate is equal to 0 is at pi over 2 and 3 pi over 2. And then where sine is equal to negative 1/2, remember you're looking in quadrants 3 and 4. So that's at 7 pi over 6 and 11 pi over 6. So any questions on example 7? Now let's take a look at number 8. Your equation already has all cosines in it. But what's the issue that we have? We have a cosine of what? That's the problem. Cosine of 2 theta. So which formula do you think we're going to have to use to get rid of that coefficient of 2 in front of theta? We're going to have to use which formula? The double angle for cosine. So now remember what I wrote down, or if you look on your blue sheet, you've got several variations of the cosine double angle formula. Remember, you already have a cosine squared. So which variation do you think is going to be the most helpful? The one where it's 2 cosine squared minus 1, or 1 minus 2 sine squared? 2 cosine squared minus 1. You don't want to use this one because then you're going to have a sine squared and a cosine squared in the same equation, which is going to muddy everything up. So we want to just do a substitution, get rid of that cosine 2 theta, and replace it with 2 cosine squared theta minus 1. So I have cosine squared theta plus 2 cosine squared theta minus 1 is equal to 5/4. Again, to get you through the algebra, if you're not sure what to do with it in terms of cosine, do that substitution and rewrite everything in terms of x. So I can rewrite this as x squared plus 2x squared minus 1 is equal to 5/4. What can we do here? Combine like terms. So what is x squared plus 2x squared? 3x squared. Any thoughts on what we could do next? Any thoughts algebraically what we could do? Do we want to set this equal to 0? No, because there's no x term. So this is where that square root method solving will help us. So what can I add to both sides of this equation? I can add a what? 1. So what is 5/4 plus 1? It's going to be 9 over 4. Because 1 is equivalent, remember, to 4 over 4. Any thoughts on what to do next? Divide by 3, which is equivalent as doing what? Instead of dividing by 3, you can multiply by what? 1/3. So x squared, what is 9/4 times 1/3 going to be? 3/4. Now what? Sure you can. Somebody just said we can't square root a fraction. Sure we can.
Oh, let's not go. Let's just stop here. This is fine. I understand that.
So, ladies and gentlemen, remember, you learned this back in Algebra 1. When you have a fraction underneath of a radical, you can break this up and take the square root of the numerator and divide it by the square root of the denominator.
Don't like that.
Well, what is the square root of 4? The square root of 4 is what? 2. So we end up with x is equal to plus or minus square root 3 over 2. Shh, guys, shh. Why are we so scared of a fraction under a radical? Why all of a sudden did that freak you guys out? You just take the square root of the numerator and you square root the denominator.
When you did it, I was like, oh yeah, I did learn that.
Yes. And you should recognize the square root of 3 over 2. Because that's from the unit circle, isn't it? So what is x, guys? What is x equal to? X, what did we originally do a substitution in here? We did a substitution for what? Cosine. So I need to know where is cosine equal to plus or minus square root 3 over 2. Where are you looking? All 4 quadrants. Yeah, Peyton.
Wait, why is it plus or minus again?
Because anytime, remember, you do square root of an equation, remember you've got to put the plus or minus in the front. Yeah, remember, anytime you do that square root method when solving quadratics. Because remember, if you square a positive number or square a negative number, they both could result in a positive answer. That's why you got to remember that plus or minus. So what quadrants are we looking? All of them. So then, what angle in quadrant 1 has a cosine value of square root 3 over 2? Pi over 6. In quadrant 2, it's going to be what? 5 pi over 6. In quadrant 3, it will be, and then in quadrant 4, it'll be 11 pi over 6. Okay? Any questions, guys, on number 8? Like I said, really, all this stuff through here was no trick. As soon as I replaced the equation with x in it, this was nothing more than solving quadratic equations, which you've done. That was all algebra. It didn't become trig again until I replaced the cosine in the end. All right? So like I said, when you have a fraction, be on the lookout, because you have that square root of 3 over 2 from the unit circle. So when you're solving those equations, you very well could end up with those fractions under a radical. All right. So let's take out your calculators. Finally, yay! Because you also, back in algebra land, have learned how to solve equations using your graphing calculators, and that doesn't change for trig equations. Okay. And ladies and gentlemen, you know you can use your calculators to solve any kind of equation. That also applies for trig equations. But on your graphing calculators, anytime you are solving an equation with a trig function, you have got to make sure you are in radian mode. Your calculator does not like graphing trig functions in degrees. So anytime you're dealing with trig in the graphing calculator, make sure you are in radian mode. Your graphs will look 100% different. You're going to get crazy looking graphs if it's not. So make sure you are in radian mode. Now, depending upon how your algebra teachers taught you to use the graphing calculators to solve equations, there's two ways you could do it. You could move everything and set everything equal to 0, and then type the entire equation under y1, and then use your zeros or find your x-intercepts for the solutions. Or your algebra teachers may have said, don't move anything around. Just take whatever's on the left-hand side of the equation, plug that in under y1. Take the right-hand side of the equation and plug that under y2, and then find the intersection point. I don't care which method you use. I'll show you how to do it both ways. So first of all, using method 1. So if I just want to set 0 on one side, I'm going to subtract the x. And then on my calculator screen, I'm going to type in a sine x minus cosine x. Make sure, guys, after you type in sine or cosine, close that parentheses after x, and then minus x. All right? So any questions what I've typed under y1? I just typed all this under my y1 right here. Again, make sure you are in radian mode. And now I'm going to hit graph. Remember, I'm looking to see where my graph crosses the x-axis because I have that one side equal to 0. Okay. So notice my graph is crossing my x-axis right here. So again, remember using your calculators, this is called your zeros. X-intercepts are the same thing as the zeros. So if I go under second trace, I can use option 2, 0. And the question the calculator is asking you for left bound, so move your cursor to the left of that x-intercept, hit enter. Move your cursor to the right, hit enter, and then enter again. So x is going to be equal, again, how many decimal places do I round to? Remind me again? 3. Negative 1.259. So like I said, the same techniques you learned back in algebra, you can use to solve trig equations on the calculator. Okay? So that's one way you may have been taught to solve equations. Another way is, again, let whatever's on the left-hand side, you just type that under y1. You type whatever's on the right-hand side under y2. So you don't have to move and get a 0 on one side if you don't want to. So under my y1, I can type in x squared. Under my y2, I can type in a negative 3 sine x. And then I just want to find the point of intersection between those two graphs. So how many times do these two graphs intersect each other? Twice. So how many solutions are we going to have? 2. So remember, you go under your second trace, and you go under option 5, intersect. So again, it doesn't matter which one you find first. I'm going to find that one furthest on the left first. So move your cursor so it's almost right on top of that point of intersection. And then hit enter, enter, enter. So remember, the x-coordinate is your solution. So x is going to be equal to negative 1.722. And then you do it again. It looks like it's 0, but just confirm it on the calculator in case you're dealing with a really small fraction. Second trace, intersect. Move your cursor so it's on close to the other point of intersection, then hit enter 3 times. So we end up with x equals 0. So there are your 2 solutions. Okay? Again, I don't care which method you use. Like I said, depending upon how your algebra teachers taught you to use your calculator to solve equations. Those are the 2 different ways you could be using. All right? So any questions on that? All right. So guys,